Hello there. So I came across the Lightroom vibrancy mode and I was wondering if I can just rebuild it in Nuke. So I did a little bit of research and found different algorithms, a little bit hidden into several forums in the internet. And since I wanted to learn C++ anyhow, I tried to make it work to pre-build it into Nuke nodes and then just try to just transfer this one into C++. And by now I have made different iterations, which you can see here with orange, red and green. So we got 1, 2, 3, and the 3 one, I think that's the best one so far. So I would like to demonstrate this. So what does the vibrancy mode? The vibrancy mode is similar to a saturation, but it's a mask saturation, meaning that it's not just plain adding saturation or reducing saturation above the entire image. So it's more like a guided thing where less saturated pixel get more saturation, non-saturated pixel get none, of course, and high saturated pixel just getting less additional saturation. So my test images were some RE test footage, some renderings I did some years ago, some HDR which I took from openfootage.net, and also some old renderings I did years ago. So the vibrancy mode in general, I try to keep it the same as the saturation mode. So as you most likely know, you just have the modes for the grayscale conversion, and then you just have a different slider for how much of saturation you want to reduce or add. So 0 is always grayscale, and above 1 you add saturation, and in between you just interpolate. So how can I show you this in the best case? So let's look at this picture here. So we have some colorful bits and pieces here and some non-saturated one and high and low values. So the first one I did was just like this, and it almost feels like a saturation, even if you can see it increases a little bit more on the saturated part. Let's bring in some saturation as comparison. So if I pump this up and just stick with 3, you see you get the overall tint gets just boosted also. So here it's very similar. It's less in the high saturated parts already, but not the approach I wanted to end up with. Now we got a second one, which has also the issue that's also a little bit tinting in the very highlights and in the image values above one. And finally, I came up with this one where I can just reduce the saturation, or just boost it, and it will all boost in the proper parts how I want it to be, so that the image appears more colorful. So if I do it like this and just add a little bit of saturation here, you see only the parts which has already color inside get boosted, and all the other ones are unaffected, and also the highlights are not treated and not going crazy, as you can see here. While in the saturation part, or in saturation normal node, you also boost this kind of highlights and get this kind of feeling which is just very artificial. So in this case, you can just bring in more color into your image and try to have a little more natural look. And as comparison, let's bring in this one. So this is the same approach here, iteration 1, iteration 2, and iteration 3. And of course I would go for the first approach where, okay, let's go into HSV or HSL, and then just boost the green channel, which is basically the saturation, and mask it a little bit. But I ended up noticing that when doing so, I may just bring this in here, you can see it better, that in doing so, that actually have always issues on the very edges. And it will also be noticeable later on. And it doesn't matter if I go to HSV or HSL, it's always is kind of this issue. And as you can see here in the second iteration, you will notice those things. And this is exact those lines which coming up. So I had to ditch the idea of going to a different color space and boost it from there. And my last iteration kind of does the trick and don't destroy the edges anymore. I mean, this is also too much in terms of saturation, but it's not breaking the edges. And did I have something else? Ah, yes, I came across some nice effect, even if it's in the second one, which is now ditched, the ditched version at the moment. So I got the first one, which is, yeah, that's the first iteration, I think it's just kind of crap. And the second one gives you a nice kind of idea to, okay, it shifts colors in different saturation levels, so you can have kind of interesting effects in here. Not saying that it's beautiful, but it's at least interesting. While the final one, you can boost and reduce the saturation based on the already existing saturation. But I think that's kind of a nice idea. Look what to achieve, and that's it. That's basically the algorithm. So going to HSL, offsetting the saturation level by 0.5, reducing it in total, and then add it back in, invert it, some gamma operation to define a little bit the mask, and then just multiply with the original one, and then add this on top. Kind of a hacky way, and it doesn't feel properly right. So I did another one, which is basically this one. So you take the maximum, you take the minimum from each channel, you subtract one from the other, invert it, and then take the max with the maximum and invert it back. So we come up with this mask, and if you look at this one and compare it to the node itself, it should be, say like this and like this. It should be the same, exactly. So I was able to transfer these things into C++, compile the whole node, and get one node out of it. Of course, this one is easily wrappable. You can just wrap this into Gizmo and have a proper Gizmo as well, which is also has the proper performance. So it's not like super slow or something, but I just want to dig into the C++ part, so and that's where I end up with. So, and then we have a proper operation to boost colors where they aren't really boosted yet without breaking the image. And that's it. Thank you.